Okay, guys. We have the circle AEB, circle AEB with center O. Okay, you can see that there's a triangle AEB also inside the circle, and then angle A is X. Okay, we can see that, and then AE is produced to D, and then we can see that AD is perpendicular to DC. They make an angle of 90 degrees. We can see that. Okay, we can also see that BD is a tangent to this circle at the point of contact, which is B, right? Okay, so with this kind of questions, guys, with this kind of questions, I prefer hore I write what I see, but without even them asking. I just put what I see. I just put what I see there. You see, so we know that an angle in a semicircle is 90 degrees. Then an angle subtended by the radius is 90 degrees. So they told us that this is the center, meaning AE is a radius. So this is the angle subtended by the radius. So B3 is 90 degrees. I can just summarize this. Angle B3 is equals to 90 degrees. Maybe ke tla kwalla ko side, right? On the paper ko side, what is my reason? It's an angle in a semi circle. It's an angle in a semicircle, right? Right? They don't have to ask. Before they will go check go the questioning or what they are asking for. Okay. So I can see B3. Okay. Don't I have an angle between a tangent and a chord? So they already told me hore BD is a tangent, right? And then BE is a chord. So this angle B2 is an angle between the tangent and a chord. And we know that an angle between a tangent and a chord is equal to the angle in the alternate segment. Okay, then we know that angle B2 is equals to X. What is the reason? A tan chord theorem. Tan chord theorem. Okay, we're doing good. What can we also see? What can we also see before going to look at the questions? Before going to look at the questions, what can we also see? Is that all? Okay. Okay, for now. For now. Okay. Let's go to the questions. Prove that BCDE is a cyclic quadrilateral. B B BCDE is a quadric lateral. So they're saying we should prove that. What do we know about the cyclic quadrilateral? We know that the opposite angles of a cyclic quadrilateral are supplementary. We can use that here. And then we know that an exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. We already said that this is 90 degrees, and they said this is 90 degrees because AD is perpendicular to DC. So we can see this angle is equal to this angle. The exterior angle is equal to the interior opposite angle, right? Okay. So we'll have to come by step, right? By step. Okay. For starters, angle B3 is equals to 90 degrees. The reason we had already given here, right? Wabona level it works well. Angle in a semicircle. It's angle in a semicircle. Okay, and then if B3 is equals to 90 degrees, therefore it means B3 is equal to angle D. They are equal to 90 degrees, right? Right, and then with this we know that exterior 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 angle of a cyclic quad. Therefore, BC DE is a cyclic quad. Why? Because this angle, which is exterior, is equal to the interior opposite angle, right? Okay, we can move along. We can move along. I need this space. I need this space here. Next question. Prove that angle C1 is equals to X. Angle C1 is equals to X. Angle C1, this one, is equals to X. Angle C1 is equals to X. Okay. You also know, guys, about angles in the same segment. So you can see that angle B2 and angle C1 are angles in the same segment. You know about angles in the yeah, it's something like this. Yeah, angles in the same segment, right? Angles in the same segment are equal. Again, we know that much. We know that much that angles in the same segment are equal, because if you look at it, they are often they are actually subtended by the same chord, or I mean by the same arc. They are subtended by the same arc. If you check this angle is subtended, if this is A and then this is point B, this angle is subtended by arc AB. This angle is also subtended by arc AB, and then obviously if they are subtended by the same arc, they should be equal, or we can even say the same chord. We know that equal chords subtend equal angles, right? So angles in the same arc. So if we look at this, they said this is a cyclic quadrilateral. It's a cyclic quadrilateral, meaning there's a circle along these vertices. There's a circle, so meaning this angle and this angle are angles in the same segment. If we are looking at this shape, this one that is darkened. So angle B2 is equal to angle C1. Why? They are angles in the same segment. But we said angle B2 is equals to x. What is the reason? Tan chord theorem. We said this angle again BD Barbuditor is a tangent, and we can see it's a tangent to the circle at point B, and then BE is a chord. So this angle B2 is the angle between the tangent and the chord, and then it is equal to the angle in the alternate segment. Again, it's equal to the angle in the alternate segment. That is the tan chord theorem. So B2 is equal to x, and then we also know that B2 angle B2 is equal to angle C1. What is the reason? Angles in the same segment. Angles in the same segment. Therefore, it says angle C1 is equals to x. Angle C1 is equals to x, right? We have proved that. Okay, moving right along. Moving right along. Prove that angle E1 is equal to angle E3. Angle E1, prove that this angle E1, this angle is equal to this angle E3, is equal to this angle E3. Okay, we just said this is x, and then if you look at it, if we look at triangle, look at triangle AEB, AEB. If we look at this triangle AEB, this triangle inside the triangle inside the circle, sorry, you can see that angle E1 is equals to 180 degrees minus. Okay, let's do it by step by step. Let's do it by step by step. We know that angles of a triangle add up to 180 degrees. So angle X plus 90 degrees plus E1 equals to 180 degrees, right? This angle, right? What is the reason? Angles of a triangle, right? Therefore, this says angle E1 is equals to 180 degrees minus 90 degrees minus x. So this is simply 90 degrees minus x. That is angle E1, right? Angle E1 is equals to 90 degrees minus x. Okay, we are happy, and then we can still again we can also again go look at angle I mean triangle EDC. Looking at triangle EDC, looking at this triangle EDC, this triangle, we have three angles. So angle E3 plus angle D, which is 90 degrees, plus angle C1, which is x, is equals to 180 degrees. The reason is this one, angles of a triangle. So you can clearly see that Angle E3 is equals to 180 degrees. 180 degrees, transpose the 90, ladies, change sign, transpose the X, change sign as also, this is also 90 degrees minus X. Therefore, we can see that angle E1 is equals to angle E3, they are equal to 90 degrees minus X. Alright? Lovely. Last question. Last question. As I wanna see numerical geometry. I love so hard. Otherwise, when the students were writing their what is that, supplementary exams? Yeah. Yo, say. No, le abanta le enkelenyana yo one and amantite the number fair. So guys want values. Guys want values. They want sizes. You just don't want numbers. See. But then it's still doable. The rules are still applicable whether it's values or numbers. Okay, so the last question is CE. Where is CE? CE, you can see CE. Is CE a tangent to the circle through A, B, and E? They're asking, is this a tangent to this circle through A, B, C? So basically, is this is CE a tangent to this circle? Nah. Is it a tangent to this circle? Nah. If CE is we don't know. Maybe I'll draw a P. Okay, otherwise from here you can say no, CE is not a tangent, it's a secant because it touches the circle twice. I mean, they clearly state that the diagrams are not drawn to scale, right? So maybe it's our error in drawing. So we need a really substantial reason, right? A reason in calculations, right? Reason that can be justifiable. Okay, so if CE is a tangent, let's assume CE is a tangent, right? If CE is a tangent, we can clearly see that BE is a chord. B is a chord, right? That's a fact. BE is a chord. So angle E2 would be the angle between the tangent, which is CE, and the chord, which is BE, right? This angle, right? It would be the angle between the tangent and the chord, right? The tangent and the chord. And then if that is the case, it should be equal to the angle in the alternate segment. So if CE is a tangent, then is E2 equal, E2 must be equal to X. E2 equals to X? Is E2 equals to X? Okay, let's check. Let's check E2. We know that E1 plus E2 plus E3 should give us 180 degrees. What is the reason? Angles on a straight line. Angles on a straight line add up to 180 degrees, right? Right, and then we know that these two are equal. These two are equal, and they are equal to 90 minus X, right? They are equal to 90 minus X. So we have 90 minus X plus E2 plus 90 minus X, right, is equals to 180 degrees. This 90 is positive, this 90 is positive. We can add them up, they will give us 100. Okay, let's do the things. It's 180 degrees minus 2x, x minus x minus 2x is equals to E2. I mean plus E2 is equals to 180 degrees, right? Right? Okay, let's transpose everything that side. Again, we are looking for the value here, E2. So angle E2 angle E2 is 180 degrees. Okay, let's transpose the 180 degrees, and then the 2x will also change sign. It will be positive. Therefore, it says this one less this is 1 is 0. Therefore, it says E2 is equals to 2x. It's not equals to x. Therefore, CE is not a tangent. CE is not a tangent to the circle at A, B and E. Thank you very much.